In February of 2021, Texas experienced one of the largest power blackouts in U.S. history. A severe winter storm caused massive demand spikes, power plant failures, and left more than 4.5 million people without electricity, with outages lasting for days in some communities. It showed how fragile the power grid can be when demand isn't anticipated in time. Hi, I'm Chai and this is my project, GridGuard. Living in Texas, the 2021 blackout was something I experienced firsthand. I lost power in freezing temperatures. In that moment, it became clear how fragile everyday life can be without electricity. Electricity isn't just a convenience. It's what keeps people safe, connected, and able to get through emergencies. That experience stuck with me and led me to a simple but important question. What if grid operators could anticipate stress coming before it becomes a crisis? That question led to GridGuard, an electricity demand forecasting system focused on grid resilience and sustainability. GridGuard predicts short-term electricity demand from an hour up to 24 hours ahead, using historical demand, weather data, and time-based patterns. Users can input real-time conditions like current demand, temperature, and time, and instantly see a forecast along with an estimated grid stress risk. The goal isn't just prediction, it's awareness. When operators know a spike is coming, they can take action early rather than responding once demand is already too high. That early awareness matters for sustainability too. When demand isn't predicted accurately, grids often fall back on emergency fossil fuel generators, options that are costly, inefficient, and highly polluting. By forecasting demand ahead of time, GridGuard gives operators more room to plan and make cleaner, more efficient decisions instead of reacting at the last minute. I built GridGuard in Python using real ERCOT Texas grid demand data from 2021 combined with historical weather data from NECI. I focused on 3 major cities, Austin, Houston, and Dallas, because they represent some of the state's largest and most distinct electricity demand patterns. I trained ML models, including random forest-based predictors, to learn daily, seasonal, and weather-driven behavior in each region, and finally deployed everything with Streamlit as a live interactive dashboard. The hardest parts of this project were the real-world details, especially cleaning messy data and getting everything to work together reliably. A lot of time went into aligning demand and weather data, handling edge cases, and making sure the models behave reasonably during extreme conditions. Because the models were trained only on 2021 data, there were cases where predictions didn't generalize as well to new or unusual conditions, revealing the importance of broader and more diverse training data. This is why, looking ahead, I want to expand GridGuard by training on multiple years of data and adding more regions to improve accuracy and robustness. With more historical context, the model can better handle rare events and shifting demand patterns. By the end, GridGuard came together as a working forecasting and risk assessment tool built around real grid data. It's a step towards helping power systems anticipate stress earlier and respond more effectively. This is GridGuard, predicting demand before the lights go out.